Welcome back to the podcast. Today, Oscar and I are diving into a really fascinating paper by Christopher Exelrod and his team, exploring what exactly happens inside our muscles when we exercise.
That's right, Andres. It's one article that specifically looks how exercise training remodels the mitochondrial fission and fusion machinery in human skeletal muscles towards a prolongation phenotype. We always hear that exercise improves the muscle mitochondrial volume and density, but this paper gets into the weeds of how the structure of this cellular powerhouse physically changes.
For some quick context, the research took 10 sedentary adults and put them through 12 weeks of supervised aerobic exercise. Unsurprisingly, the training led to reduction in body weight, fat mass, and fasting glucose, while improving aerobic capacity and insulin sensitivity. But the real magic was in the muscle build.
Exactly. When they analyzed the muscle tissue and normalized the data for change of mitochondrial content, they found the exercise actually reduced the expression of two specific proteins, FIS1 and Parkin.
Which is such a wide finding. FIS1 is a protein that regulates the fission machinery to the mitochondria, and Parkin regulates mitophagy, meaning the cellular clearance of damaged organelles. You think that exercise, which creates oxidative stress and bioenergetic demand, will increase the need of mitophagy to clean up the mess? That was my biggest question going into this paper. Why will a healthy habit reduce the cellular cleaning up creep?
It's a great point, and it's been of my concern when interpreting this data. Initially, I thought maybe reduction in Parkin means the mitochondrial weight accumulation damage, but the author explained it's a bit folly. They are the chronic exercise creates a perfusion environment where the mitochondria integrate into large, elongated network because this overheads metabolic function and architecture in network is better. They are fiber demand fragments that actually need to be recycled by Parkin.
Right, so it's less about the garbage truck breaking down and more about factory producing less garbage in the first place. The research found that the ratio of fusion to fission proteins increased significantly. Even better, that improving the radio correlated strongly with improvements in the body glucose disposal. Basically, the more fusion your mitochondria, the better your body handles blood sugar.
And this is where we can bring some of our perspective. Other studies show that bioenergetic stress from nutrient oversupply, like high sugar or high fat environments, force mitochondria to fragment. That fermentation is closely likely to metabolic tissue like obesity and type 2 diabetes. So, by doing aerobic exercise, you are quite literally leveraging the structural damage at the mitochondrial level from a healthy tubular network.
Which leads me to a big discussion point for our listeners. If aerobic exercise promotes this fused, elongated mitochondrial network, what about resistance training? Does lifting heavy weight trigger the same structural remodeling, or does it require the continuous energy demand of cardio? The authors themselves noted that their investigation was limited to assessing the proteins governing these processes, and that more detailed, imagine-based studies are underway.
That is the $1 million question. Plus, we have to wonder how nutrition plays into this. If you exercise but still consume an hypercaloric diet, does the nutrient-induced fermentation cancel of the exercise-induced infusion?
Such a great thought experiment. It really shows that there's still so much to uncover about the biology of exercise. We'd love to hear what you all think. Drop a comment on your page. Do you think your lifting routine is fusing your mitochondria.
Thanks for tuning in, everyone. Catch you in the next episode. Bye bye.